So let's continue our discussion of summations. Let's look at the following problem. What is the value of 2 to the 0 plus 2 to the first plus 2 squared plus 2 to the n when n equals 0, n equals 1, and n equals 2? So here, if I look, this is a summation, so I can write it in summation notation, right? 2 to the 0 plus 2 to the first plus 2 squared. These are all powers of 2, so my formula for my summation, it'll be 2 to the I, and I is going to start off at 0. So my first term is 2 to the 0, and my last term is going to be n, because my last term is 2 to the power of n. So from here, it's just asking me to plug in these values for n and compute the summation. So let's plug in. If n equals 0, we're summing. Remember what happens, we saw an example of this before. If your upper and your lower bounds are the same, it's really just one number. It's 2 to the 0, or just 1. So there's really nothing for you to add here. If n is 1, summation from I equals 0 to 1. So here I'm adding 2 to the 0, and I'm adding 2 to the first, and getting 3. And lastly, it asked for what happens when n equals 2. I equals 0 to 2. So 2 to the 0, 2 to the first, 2 squared, or 7, if I add all those together. Now there are a couple things I want to make sure and note here. So if I sum up from I equals m to m of AK, that's just AM. We saw that before. And also, let's think about when I was computing n equals 2. Right? If I look back here, I had to, if I just look at these first two terms, this was really the same thing that I computed back here. So really, if you're summing up from k equals m to n, you can sum up everything but the last term, and then add on that last term. So I could have taken my previous sum of 3 and just added on that one extra term of 4 to compute that sum. Or sorry, that should be an, not am. So if I'm adding up a bunch of things, I can add up all of them but the last one, and then add the last one later, after the fact. Let's look at one final example. Using the identity. So the identity I'm going to give you is 1 over k. So these are two fractions that I want to subtract. Remember, if you're subtracting fractions, you got to get a common denominator here. My common denominator would be k times k plus 1. So then this difference is really equal to 1 over k times k plus 1. So this is the identity here. On this last line, that's my identity. So I want you to use the identity to find a simple expression for this summation. K equals 1 to n, 1 over k, k plus 1. So here I can use that identity to rewrite these terms, the summation from k equals 1 to n, 1 over k minus 1 over k plus 1. And now let's start writing out these terms here. So if I plug in 1 for k, you'll get 1 over 1 minus 1/2. Plug in 2 for k, 1/2 minus 1/3, 1/3 minus 1/4. And then second to last, I would plug in n minus 1. And then lastly, I would plug in n for k. And let's see what happens. So if I look here, notice this negative 1/2 will cancel with this positive 1/2. The negative 1/3 will cancel with the positive 1/3. This negative 1/4 would cancel with the positive 1/4 in the next term. And then this negative 1 over n will cancel with this positive 1 over n. So in the end, I'm just going to be left with 1 minus 1 over n plus 1. So there's our nice simple expression for this summation. So if you've taken Calculus 2, you saw this. This is a telescoping series, essentially. The same idea is occurring here. Okay, you're having terms that are canceling with previous terms, and so it simplifies to this nice simple expression here.